The concept that your body contains stardust is one of the most profound and awe-inspiring revelations of modern science. It all begins with the life cycle of stars, particularly massive ones. In the early universe, the only elements that existed in abundance were hydrogen and helium, the simplest atoms. As stars formed from these gases, intense heat and pressure within their cores caused nuclear fusion to occur. This process fused hydrogen atoms together to form helium, and over time, stars began to fuse heavier and heavier elements, like carbon, oxygen, and iron. These elements are the building blocks of everything we see around us. However, it's in the death of stars where the real magic happens. Massive stars end their life cycles in colossal explosions called supernovae. When a star goes supernova, it expels its outer layers into space, scattering the elements it created during its lifetime across the cosmos. These scattered elements, carbon, oxygen, nitrogen, calcium, iron, and many others, are the raw materials for new stars, planets, and eventually, life itself. Over billions of years, these elements traveled through space, eventually coalescing into new stars, planets, and moons. Our planet, Earth, formed from this cosmic dust about 4.5 billion years ago, but it doesn't stop there. The very atoms that formed Earth are the same atoms that make up every living thing on it. The carbon in your muscles, the calcium in your bones, the iron in your blood, all of these elements were forged in the hearts of ancient stars and flung into space by supernova explosions. To put it simply, almost every atom in your body, except for the hydrogen, which formed shortly after the Big Bang, was created inside a star that lived and died long before the Earth even existed. When Carl Sagan famously said, "We are made of star stuff," he was summarizing this incredible truth. You are, quite literally, a collection of star matter. Your body, in all its complexity, is a testament to the universe's capacity for creating and recycling itself. The fact that Earth contains more trees than there are stars in the Milky Way is a surprising and fascinating piece of information that underscores both the vastness of life on Earth and the immense, yet countable scale of the universe. Let's dive into the details to fully appreciate this extraordinary comparison. First, let's break down the numbers. Recent scientific estimates suggest that there are around 3 trillion trees on Earth. This number comes from a large-scale study conducted by a team of researchers led by Yale University in 2015. Using satellite data, ground surveys, and computer models, the team calculated the global density of trees across different ecosystems, resulting in this mind-blowing figure. To put this into perspective, that's 3 trillion individual trees spread across the planet, from the dense tropical rainforests of the Amazon to the vast boreal forests of Siberia and Canada. This number includes a wide variety of species, from towering redwoods to small saplings, all contributing to this incredible total. While human activity, particularly deforestation, has reduced the number of trees significantly over the past few centuries, there are still far more trees on Earth than most people might imagine. Now let's turn to the Milky Way galaxy. Our galaxy is vast, spanning about 100,000 light-years across, and home to a wide range of astronomical objects, including stars, planets, nebulae, and black holes. The number of stars in the Milky Way has been estimated to be between 100 billion and 400 billion. While this is an enormous number, it's still only a fraction of the total number of trees on Earth. Even at the higher estimate of 400 billion stars, the number of trees on Earth exceeds the number of stars by at least a factor of 7. Octopuses are remarkable creatures, in part due to their unique circulatory system, which includes 3 hearts and blue blood, adaptations that help them survive in their often cold and low-oxygen marine environments. 2 of the hearts, called branchial hearts, are located near the gills. Their primary role is to pump deoxygenated blood from the body to the gills, where oxygen is absorbed from the surrounding water. After oxygenation, the blood is then transferred to the 3rd heart, the systemic heart, which pumps the oxygen-rich blood to the rest of the body. What's particularly interesting is that the systemic heart actually stops beating when the octopus swims, likely a mechanism to conserve energy, as swimming requires intense bursts of activity. This feature explains why octopuses, though capable swimmers, often prefer to crawl along the ocean floor rather than swim for long periods. They tire quickly when swimming because only the branchial hearts are functioning during this time. But that's not where their uniqueness ends. Octopuses also have blue blood due to a copper-based molecule called hemocyanin, which is used to transport oxygen. Unlike the iron-based hemoglobin in human blood, hemocyanin binds to oxygen more efficiently in cold, low-oxygen environments, which is crucial for octopuses that often inhabit deep-sea areas. The copper in hemocyanin gives the blood its distinctive blue color when oxygenated, in contrast to the red hue of hemoglobin-based blood. Together, these adaptations, 3 hearts and blue blood, allow octopuses to thrive in environments where many other animals would struggle, making them some of the most fascinating creatures in the ocean. It may come as a surprise, but bananas actually contain a small amount of radiation. This is because bananas are rich in potassium, a vital nutrient for the human body. Potassium is essential for many biological processes, including maintaining proper heart function, muscle contraction, and nerve signaling. However, a tiny fraction of the potassium found in bananas exists in the form of an isotope called potassium-40, K40, which is naturally radioactive. Potassium-40 is a naturally occurring isotope present in all potassium, and because bananas are packed with this element, they emit a small amount of radiation. This phenomenon is often referred to ingest as the banana equivalent dose, which is used to illustrate how common radiation is in our everyday lives. In reality, the amount of radiation in a banana is incredibly small and poses no harm to humans. To put it into perspective, you'd need to eat about 10 million bananas in a very short period of time to experience any harmful effects from the radiation alone. In fact, the radiation emitted by a banana is so insignificant that it's less than the background radiation you're exposed to on a daily basis from the natural environment, including cosmic rays from space, the ground beneath your feet, and even the air you breathe. Despite the radioactive nature of potassium-40, it's important to understand that radiation is a natural part of life, and the body is well equipped to handle the tiny doses we encounter. The amount of radiation in a single banana is estimated to be about 0.1 microsieverts, which is a trivial amount compared to a typical annual exposure of 2,000 to 3,000 microsieverts that the average person receives just by living on Earth. Bananas, like many foods, contain trace amounts of naturally occurring radioactive elements, but their health benefits far outweigh any negligible radiation risks. So while it's fascinating to think that bananas are technically radioactive, the levels are so low that they are perfectly safe to eat and remain an important part of a healthy diet. One of the more astonishing and curious discoveries in space is the presence of a giant cloud of alcohol floating in the Milky Way. This massive alcohol cloud, located in a region of the galaxy called Sagittarius B2, lies near the center of the Milky Way and spans about 463 billion kilometers in size. The cloud is composed primarily of ethyl alcohol, the same type of alcohol found in alcoholic beverages like beer, wine, and spirits. However, before we get too excited, it's important to note that this alcohol is not drinkable, as it is mixed with other toxic compounds like methanol and other complex organic molecules. The discovery of this cloud is not only mind-blowing due to its size, but also because of what it represents. Ethyl alcohol is one of the many organic molecules found in interstellar space, and its existence in such abundance gives scientists important clues about the molecular chemistry that occurs in space, and how these molecules might contribute to the formation of life-supporting compounds. Sagittarius B2 is located near a region that is rich in star-forming activity, and the cloud itself is thought to have originated from the complex processes that take place when stars are born. Within this cloud, dust grains and gas molecules are interacting, and over millions of years, these molecules have been forming various organic compounds, including alcohols, aldehydes, and amino acids. The conditions in space, particularly the extremely low temperatures and high levels of radiation, allow for the slow but continuous formation of such molecules. Incredibly, scientists estimate that this interstellar alcohol cloud contains enough ethanol to produce 400 trillion pints of beer. While it sounds like an astronomical happy hour waiting to happen, the alcohol in this cloud is far too dispersed and mixed with other harmful chemicals to be of any practical use.